Okay, in this video we'll talk about the relationship between circular motion and simple harmonic motion. Okay, so if I can take you back a bit, we understand the concept of circular motion and the concept of simple harmonic motion. Okay, so the motion that repeats itself. So even in circular motion we know that the motion that repeats itself. So if I can take you back a bit, if we can remember, if we have a circle, circular motion, a motion along the circle. Okay, so if we have the circle and let's say an object is moving along the circle, okay, we have, maybe we have x, it's moving from x, or an object is moving there. So if maybe it's moving from this point to that point, okay, so if I see, if maybe you view it in this particular manner here, you view it from there, what's going to happen is that you are going to see a motion, you are going to see the x in this direction, it's going to move in that direction. Okay, what if you continue doing it there? So as you continue doing it, what you are going to see is this. If you do this, you continue viewing, you view it at that particular point, you view it from here, you start from there, you view it from there, what you are going to see is this. This is what you are going to see. Okay, you are going to see that you are going to have the x there, and you are going to have the a there, here, which is the same as the amplitude. So as we can see, this is the circle, but a is the same as the radius in this case, and we are now talking about the circular motion. But as we can see, we have viewed this circle in 4 points. Therefore we can say we also have 1, it goes there, it goes there, it comes back, and it brings us back to simple harmonic motion. So we want to see the relationship between the simple harmonic motion and the circular motion. Okay, so if we can understand very well this point, then we are going to solve the questions. So there we go, let's start. Now we need to understand that velocity is distance over time, or displacement over time. But the distance in this particular case, it is just the distance, the circumference of the circle. So the distance is 2 pi r. That is the distance we are talking about. Okay, and the time which we are talking about here, we are talking about the period, the time it takes to complete, for us to complete one cycle here, to start from this point up to this arrow here, or let me say this is arrow 1, this is 2, this is 3, this is 4. So to start from arrow 1 to arrow 4, to that line, to complete that circle is what we call the circumference of the circle. So the distance, for us to calculate that distance, the distance is 2 pi r. That is the distance. So now the time it takes to complete one cycle is the period, meaning we can replace t with the period. Simple, right? So now in this equation, the same equation, what can we do? Okay, so in this equation we are going to replace v is going to remain the same. Here d we are going to put 2 pi r, the radius, over the period. Okay, perfect. I want to find the time. I'm going to cross multiply both sides. I'm going to have vt is equal to 2 pi r over v, and I'm going to have my t as equal to 2 pi r over v. Okay, so if we can recall very well, we say the v, this is the basically what we're talking about here. If you can remember, when x was 0, meaning we had the maximum velocity. So the velocity which we are talking about here, we are talking about the v max. So if you can recall, we said the v max is equal to the square root of k over m times a. So we can replace this guy with where there is what? Velocity down there. So what are we going to have if we replace that? Or if we don't replace that, but we can just solve from here. Let me create the space. Okay, so let me light this on top. We are saying v max is equal to the square root of k over m times a outside. So if I solve a, because if I solve a there, what am I going to have? Okay, if I solve a, what am I going to have? So I want to solve a. I'm going to divide both sides by, it's the same as I just get the reciprocal of this one. Okay, so if I do both sides times, or maybe you can't understand from here, let me do this. Let me create the space there so that at least, so if I do times the reciprocal of, I do m over k, I'm going to discover to say this and that one is going to be cancelled. I'm going to have the v max times the root of m over k is equal to a, the amplitude. Let me take you back a bit. We are saying this a which we have the amplitude there, it is the same as the radius, so it is the same as this guy here. Therefore this a, I'm supposed to substitute it there, meaning my time comes here to say 2 pi a over the v max. Okay, so where there is a, I'm going to replace with v max times that one. So I have t is equal to 2 pi, where there is a, I'm going to do multiply by v max times the square root of m over k over, I have v max down. Wonderful. So I know that v max and v max can go. Okay, v max and v max can go, and I'm going to have my period as 2 pi times the root of m over k. So this is the formula which we can use to calculate the what? The period. Now what of if we want to calculate the what? The frequency. We said the frequency is the reciprocal of the period. And how can we do that? So we know that frequency is equal to 1 over the period. So if this is my period, I can just do my frequency is equal to 1 over 2 pi, but here is supposed to change again. It's supposed to be k over m because I'm getting the reciprocal. So I'm supposed to say times k over m, meaning that is the frequency. That's how we can calculate the frequency. Perfect. Okay, now let's check, let's do one example from here. Let's do one example. Okay, so let's say let's do one example. Okay, let's do one example. Let's say maybe we have a spring. We have a spring. We have a spring, and we have the mass of 0.5 kgs. and you are applying this force with what, 100 newtons. Then what happens? Maybe let's say this is our equilibrium position. So from this is our x, so this distance there, let's say we have 0.3. Okay, so if we have 0.3 there, then how can you calculate the frequency and the period? Okay, upon knowing that, how can you calculate that? Okay, so if we can remember very well, we said the period, or we can start with the period. Yeah, so we start A, we need to calculate the period. How can you calculate that? So the period is equal to 2 pi times the square root of mk. Yeah, mk. Now if that is our period, mk, then we can have everything, but we don't have the value of k. But we know that the force is equal to kx. I have my x, I have my k. So I have my force as 100 is equal to, I don't know k, I have my x as 0.3. Therefore I'm going to divide both sides by 0.3. K is equal to, so I'm going to be 100 divided by 0.3. My k is 333.3 Newton per meter. Okay, so if that is my k, then I can come back here. I have my period, to say my period is equal to 2 pi times the root of, the mass is 0.5 over 3. So what will be my answer? Okay, I get my calculator. 0.5 divide 3.3 times pi times 2. Okay, so I'm getting I'm getting the period as 0.009. 0.0094 seconds. Okay, or we can say period is equal to 0.01 second. Wonderful, right? Okay, so we come now to frequency. How can we calculate the frequency? So we know that frequency is 1 over period. So frequency is equal to 1 over 0.01. And we can find that as 1 divided by 0.01, 100. So we have our frequency as 100 Hz. Perfect. Okay, now what if we have something else? What if we have a circle? Let's erase this. Okay, what if we have something else? If we have a circle, then let's say maybe we have that. Let me draw the circle. If I have that, then I can have, let me use the different color. if I can make that, we are still talking about that the same thing, but we have a still here we still have so now let's say we have theta there, the angle. What will happen if we can equal cos? If we want to find the cos theta, okay, it's going to be our x over a. That's what we know from cos. Then if I want to find the x, what do I do? I'll cross multiply. I'll have x is equal to a cos theta. Okay, again, if I take you back a bit, if we can remember something, let's remember something. Under circular motion, we said distance is equal to v times time. Then linear displacement is equal to the angular speed times time. Then the angular speed is 2 by f. Okay, so if x is equal to let me do this, don't want to confuse people. From what I've drawn here, if I want to find cos from using SOHCAHTOA, if I want to find the cos, we know that cos is equal to adjacent, this is my adjacent x, over hypotenuse. Hypotenuse is a. So I'll come here and say cos theta is equal to, my adjacent is x, my hypotenuse is a, but I want to find the value of x. How can I find? I'm going to cross multiply. So if I cross multiply there, I'm going to have a cos theta. But this theta, if you can check this theta here, it's the same as what we have there. Therefore, I can replace where there is theta with the wt. Okay, so that's what I'm going to do. So I'm going to say x is equal to a cos open brackets wt, meaning this is the formula which I can use to calculate the what, the displacement with the function of time. So if I have the time, I can plug in those values I find. But again, if I don't have the angular speed, what can I do? I have the frequency. I also know that the frequency which I have here is the same as what I have there. So what do? I just plug in there. I'll replace, I'll say a cos open brackets 2 by f t. So this is the as the function of time, a cos 2 by f t. Those are the formula we are supposed to use when calculating that. Okay, so now here we need to know how we can calculate the, so I can just erase this because I'm done with it. We have find one equation. We have find one equation which is, we have said x is equal to a cos open brackets 2 pi f times t. That's what we have said. Now we want to differentiate this function in terms of t. Okay, so I can erase this. That is the function calculating the what, the x, if I've been given the time. That is the formula which I can use. So I can use that as the function of time. Function of time. Okay, so now if I differentiate that function, what am I going to have? We differentiate in terms of t. What do? Okay, we take you back. So if I differentiate that in terms of t, then I'm going to find the velocity. So meaning I'm differentiating this now, meaning I'm going, if the moment when I differentiate this one, I'm going to find velocity in function of time. And how do I do that? Okay, so the derivative of course is negative sign. So I'm going to write a open brackets negative sign, but the way we differentiate the function with the trigonometric function, or let's say maybe we have cos. Let me do the example for cos. If I have cos 2x, if I want to differentiate this one, it is negative sign. I keep the what is inside constant times the derivative of what is inside, which is 2. Therefore it's going to be negative 2 sine 2x. That is the derivative. So now let's now differentiate that one which is on top. We differentiate that one. How can we do that? Okay, if I'm to differentiate that one, I'm going to get sine there, then I'm going to keep what is inside constant. Sine, then I'll have open brackets, or let me use another color there. Okay, perfect. I'm going to have negative sign, open brackets. I'll keep what is inside constant, and times the derivative of what is outside. So the derivative of that guy, we are going to get 2 pi f. That's what we're going to get. Okay, so if we can remember very well, we said the frequency is equal to 1 over 2 pi times the square root of k over m. Again we said the amplitude is equal to V max times the root of m over k. This is what we said. And if we can see our equation, we have the V max as well as the what? We have the V max as well as the amplitude as well as the frequency. So we can replace these guys with what we have there. Then, so we are going to replace this frequency here with what we have there, amplitude with what we have here. So we continue. We are going to have the V, the function of t, is equal to a. I'm going to replace there with V max times the root of m over k. Open brackets, negative sign, open brackets, 2 pi f t cross. I have 2 pi. Where there is f, I'm going to replace with 1 over 2 pi times the root of k over m. Okay, so now upon knowing that, then we can do something else. As we can see, these two guys, they can cancel each other. Again, these two guys, they can cancel each other. What do we have now? Now we are going to get a function as negative V max sine 2 ft yeah. So this is what we are going to get, because we have cancelled this, and this is what we are going to remain. This is what we are going to remain with. So it is negative V max times sine, open brackets, 2 pi ft. But again, we know that 2 pi ft is just basically, so if you want, again, you can reduce it. You can say negative V max sine, open brackets, wt. It's the same thing. Again, if I differentiate this guy in terms of time, or yes, in terms of time, if I differentiate this one, the function which I have now, and I'm going to calculate the acceleration now. So what can we do now? Let's do this. So we can write it on top there. We are saying V as function of t, negative V max times sine, open brackets, wt. Or if I don't want to include that one, I can put 2 pi ft. Okay, so now what if I differentiate again that one? What am I going to get? So for us not to be confused, let's replace this guy with 2 by f. Okay, so if I want to differentiate that one, the derivative of sine is going to be cos. It's going to be negative, so v doesn't change. Okay, v doesn't change, but we know that v max is equal to the square root of k over m times a. Okay, so we are going to replace there, but we are just differentiating that one in terms of time, so we are going to replace later. Okay, so what can we do? We are going to say v max, we have v max, the derivative of that one is cos, so I can put them in brackets. I say cos, then I'll keep what is inside constant, like what we did last time, times the derivative of what is inside. See what we're going to have. Okay, what else am I supposed to do? Okay, so I'm going to say, so v max I'm going to replace with that one, so I'm going to have negative the square root of k over a. Then the 2f 2 pi f, we know that f is just basically the frequency. We said it's going to be 2 pi 1 over 2 pi times k over m. This is what we're going to have. So as we can see from here, we can come up with the conclusion to say, since these two guys are equal, they are going to cancel each other, but we have this guy here and this guy here. If I do the math there, they are going to cancel each other. The square root is going to go. Therefore, I'm going to have this negative k over m a. This is k. Okay, this is what I'm going to have. Okay, now after having that one, then we can just rearrange them to say a is negative k over m times a cos 2. Or let me remove the brackets. Okay, so that is them. So these ones we're supposed to put them in brackets, but we'll do something else. We can use that formula to calculate that, but again we are supposed to simplify things. So how do we simplify it? This is what we do. So this is what we do. We need to recall that acceleration, we said acceleration is equal to what? If we can remember very well, we said our acceleration maximum is equal to k over m times a. But if I can see this guy here, it's the same as what I have there. Therefore, I need just to replace there. I'm going to say negative acceleration max times cos open 2 by ft. So this is the formula for calculating the what? The acceleration of the function of time. But there are some other formulas which we can use when it comes for when we have been given some other details. And how do we do that? Okay, so these ones we can just list them here. So these formulas, we have come up with these 3 formulas, but there are some also 3 formulas which we can use to calculate the acceleration, the velocity, and everything else. Okay, and what are those formulas? So those formulas are very important. We are supposed also to know them. Okay, so the first formula which we are supposed to know again is let's review. The first formula which we are supposed to know again is okay, so we can start. The first formula okay, so the first formula, the function of time, or distance with the function of time. If we don't have something else, although this one remains the same, we said cos w. So this one, it can be angular frequency or angular speed. It's the same thing. So here we're talking about the equations or equations of position with the function of time. That's how we can do that. What of the second one, when we want to calculate the what? The velocity. So the velocity, the function of time, is given by negative a w times sine, although it's just the same thing what we were doing. Then this number 3, we have the acceleration. So this is when we have been given the angular frequency. These are the formulas now we are supposed to use. So we just when we have been given the angular frequency, these are the formulas which we can use. Thank you for watching this video.